Hey everyone, today we're going to talk about solving trig equations, and this is actually the first part of it. We're just going to do the basic linear type equations today, and then on Monday we'll get into the quadratic forms of the equations. Okay, but today I want to just talk to you about how we're going to do this. So this is your note sheet. I'm only going to be doing the first 4 problems on your note sheet, and we'll finish up the notes in our next class. But let's go over these. The idea behind solving these equations is that you want to just treat your trig function, in this first problem that's your cosine theta, you want to just treat that like a variable. So if I gave you the equation, and I'll just write it next to it here. If I gave you the equation 2x minus 1 is equal to 0, and I asked you to solve for x, well, you would just add 1 to both sides, right? And then divide both sides by 2, and so you would get x is equal to 1/2, right? Very straightforward. This is the exact same thing. You are solving for cosine theta first, and then we'll figure out what theta is. Okay, so the first thing I'm going to do is add 1 to both sides, and that gives me 2 cosine theta is equal to 1. And then if I divide both sides by 2, I get cosine theta is equal to 1/2. And now you want to say to yourself, okay, I know that's 1/2 is from one of my special right triangles. Right? If I draw out my 30, 60, 90 triangle, here's 1, √3, and 2. The angle whose cosine is 1/2 is 60 degrees. So I know that theta would be 60 degrees. Now here is where you just have to kind of think through the problem a little bit, because most people would stop right there. But here's the thing, they're asking for all of the answers where theta is in this interval. So basically from 0 to 2 pi, that would include everything, right? Starting here and going all the way around to here. So remember, this is A, S, T, C. Okay, cosine is positive in 1 and 4, which means this is my first quadrant angle. In the fourth quadrant, it's going to be 360 minus 60 degrees, which would be 300 degrees. Now, because the interval is in radians, my answers need to be in radians. So 60 degrees in radians is pi over 3. And 300 degrees in radians would be 5 pi over 3. So your answers here are pi over 3 and 5 pi over 3. So let me walk through that one more time, what I just did. I solved the equation first for cosine theta, and then I found what theta was. I know that the angle whose cosine is 1/2 is 60 degrees. I get that from my special right triangle. Because cosine is positive in 1 and 4, I also need to find what it is in the fourth quadrant. So I'm just doing 360 minus 60 degrees, and that gives me 300 degrees, and then I converted them into radians. Remember, I have to give all answers in the interval from 0 to 2 pi. Okay, now again, you might be saying, wait a second, why is it, how did you know it was 300? Remember when we talked about reference angles, and we said you always are using your reference angle, and you're measuring how far you are from the x-axis. Remember that once you get out of the first quadrant, right, this is the first quadrant, once you get out of that, then you're using that angle as your reference angle. So I just did 360 because I'm in the fourth quadrant, so I did 360 minus 60. And that brings me back down. Right, so this angle right here is 300 degrees. Okay, let's go ahead and try another one. In problem number 2, again, I'm going to do that same thing. So I'm going to add 5 to both sides. And here I have 3 sine of theta is equal to 9. And if I divide both sides by 3, I end up with sine of theta is equal to 3. And from there I would say, wait a second, I can't actually do that. If you grab your calculator and you tried to find the angle whose sine is 3, right, I'm trying to find the angle. Make sure I'm in the right mode here. Let me go down to degrees. If I try to find the angle, I'd have to do second sine of 3. And if I do that, notice I get an error message because that's not possible. So for this particular problem, we would say does not exist because we can't actually do it. Okay, so sometimes there's a problem that you can't actually solve. Let's look at the next two problems. So in number 3, we've got root 2 cosecant x plus 2 equals 0. So first thing I'm going to do is subtract 2 from both sides. So I have root 2 cosecant x is equal to negative 2. And then if I divide both sides by root 2, I have cosecant of x is equal to negative 2 over root 2. As soon as you see root 2, that should tell you that you're dealing with your 45, 45, 90 triangle. So we've got 45, and remember this is 1, 1, root 2. Right? So if I were to rationalize this, right, I'd multiply the top and the bottom by root 2, and that would give me negative 2 root 2 over 2. Those 2's cancel. That gives me negative root 2. Remember, cosecant flips sine. So it's going to be hypotenuse over opposite. So hypotenuse over opposite would be root 2 over 1. So that tells me that my angle is going to be 45 degrees. Now, because it's negative, I can no longer be in the first quadrant. That automatically makes this a reference angle. Okay, my reference angle is going to be 45 degrees. So now think of what quadrants you are in. Cosecant does what sine does. So wherever sine is negative, cosecant will also be negative. Sine is a negative in 3 and 4. So to find it in the third quadrant, right, here would be my angle. So here's my reference angle of 45. That means I have to take 180 degrees plus 45, right? So in that third quadrant, my angle is going to be 180 plus 45, which is going to be 225 degrees. And then in the fourth quadrant, my angle goes this way because it's always your distance from the x-axis. Here's 45 degrees. So if I do 360 minus 45, that gives me 315 degrees. So those are my two answers. Now again, I have to put them in radians. So to convert to radians, remember you're just doing pi over 180 if you don't remember. Oops, let me clear that out. So I have 225 divided by 180. That's going to give me this. If I convert that to a fraction, math, enter, 5/4. Right? So this is going to be 5 pi over 4. And I can do the same thing with 315. And that's going to give me 7 pi over 4. So my answers here are 5 pi over 4 and 7 pi over 4. Okay, we'll go ahead and do one more. In this particular problem, we have sine on both sides. Treat it just like a variable. I'm going to subtract 15 sine of x from both sides. Right, so that's going to give me 16 minus 15 just leaves me with 1. So that was going to give me sine x plus 20 is equal to 19. So sine x is going to equal negative 1. Well, think about your sine curve. Where is your sine curve equal to negative 1? Remember your sine curve does this. Right? This right here is -1. That's -1 right there. That happens at 3 pi over 2 on your graph. So your answer here is just 3 pi over 2. That's the only time it hits -1, so that's your only answer. So again, once you find that value for x or theta or whatever the variable is, then you have to go through the process of figuring out which quadrant it's in, and then figuring out the measure of the angle in that quadrant, and then finally converting it into radians because your interval that they wanted the answer in was in radians. Okay, so we will talk more about this next class, like I said, but this should help you with the assignment. Thanks, everyone. Have a great day.